This is the second video, assignment 14, dealing with just informational things I think that are important. And when you want to talk about statistics displays. So I'm going to talk about pretty much everything that could be on the SAT. So this video might be a little bit longer, but bear with it if you really want to get the lowdown on all the possible statistics that could be asked. The video coming before this is more important, though. You're going to get more questions on in the style that you saw in that last assignment. So if you have a set of data, and I'm going to just talk about through the percentile here. What's true about all of this? You know, how do you calculate it? So the mean is simply the sum over the count. So we have a count of 18, and we're going to sum all 18 up and then divide by 18. So in that, there are two numbers in the middle position, 79 and 81. So when we figure out the middle position, we have to average those two. That's just a note there. 75 is the most repeated. That happens 1, 2, 3, 4 times. 55 is the range, so 95 minus 40 on that. And we'll say 4 times here. It's no mode if there's no numbers repeated, and there can be many modes. Lower extreme and upper extreme speak for themselves. What about the quartiles? So the quartiles is simply you group the numbers into 2 equal sets and then get to the middle of each of those sets. So I'll use a different color marker here so you can kind of strike out and get to the middle. So there are, let's see, 1, 2, 3. I need another one here. 4. 1, 2, 3, 4. So here's the lower. And then so you want to make sure in your 2 groups that you have equal numbers. So we have 18, so 9 are going to be in both. If you have an odd number, then you just leave the middle one out. So we get to the middle here, and that's 87. So that's the upper quartile. So median of the lower half of the set of data, median of the upper half of the set, and you perform it in the same way as you do the main median of the whole set. And if there's an odd number, you just simply leave the middle number out and you group the rest into 2 equal sets. Here there was an even number of data, so you got to group all the data. Interquartile range, we talked about that. Calculation for outliers, I wouldn't worry about that. What an outlier is it's a data element that's far removed, and you usually can tell by looking, oh, 40. That's way down there, so that usually just by looking you can tell what's going on. Percentile is the percentage of people or percentage of whatever it is here, numbers that the chosen data element is equal to or better than. So it's a ranking percentile. You've heard that. So it's in 13th place out of 18. So what percentage is that? 72.2. So you go to the last 84 if there's more than one, and then look at that. So these are the basic calculations to be aware of. A lot of times you have to figure out, like you might have 3,000 data elements. What's the middle one? What's the middle position? Or let's say 3001. And so you have to be good at getting to the middle of a new, you know how many data elements there are, and figuring out the middle position a lot of times. And you saw that in the last video to know where the median is. Okay, so the rest of this is just stuff I think that's important, and I'm going to go pretty quickly through it. So this is drawing on the first set of numbers you saw, and I've got it listed at the top there. So what if, we were trying to, do a circle graph, and from the display of calculating things here to make a circle graph, I would tell you that this for sure would be what I would write in this circle graph. So it's a percentage out of the whole, like a straight percent. So like 1 out of over 18 is the percentage probability sometimes of the 40 through 49 and 60 through 69. And then you multiply that by 360 to get the angle. So there will be questions with circle graphs. So it's just a piece of the whole. It's a straight percent beast based on 360, or the two most important numbers are 360 and some number that might represent something else. So we're going to actually get to some problems later on in this video. And to keep the video shorter, you should read through these things that I have circled on this. I'm not going to talk about them, but I wanted to make you aware of a circle graph. They're very important. And the two numbers, 360 degrees, and then some total of something that you're talking about. Here, we're just talking about numbers and numbers coming from this. Very, very important in the figuring out. And so as you sum these, the sum of the percentages, barring rounding errors, should be 100. The sum of the angles, barring rounding errors, should be 360. Box and whiskers. So you've seen these, and each of these represents 20, they're the boundary values for 25% of the data. So this, when I look at this, I see a lot of the data that's skewed to the right, more closer to the highest score, we'll say. So box and whiskers are designed to demonstrate dispersion of data. You're definitely going to be able to tell if there's an outlier there, something that's far removed, but it represents equal amounts of values approximately in each quartile. So the first quartile, if we didn't throw the 40 out, has boundaries of 40 to 75. We use the upper one. The second quartile, 75 to 80. Again, we use the 80. Third quartile, 80 to 87. Again, we use the 87, the upper boundary. And then the fourth quartile, 87 to 95. We use the 95. And remember, interquartile range, 87 minus 75, which is used in calculating outlier boundaries. Okay, bar graph just has categories on the x-axis. Here we have a scaled x-axis. That's what that word says. And so that's the difference between a histogram and a bar graph. So histograms have scaled. This should have been number one. Scaling on the x-axis. So that's a little bit goofy with how that works. So with this, the scaling would be, ignore the 0.5s. This is a statistic thing. So like 40s, 60s, 70s, 80s, and 90s, and then you're counting the frequency of data elements in those intervals. But you can circle these, read through them. The big statements down here, the scaling on the x-axis, very important. Pareto chart. This is if you're trying to really jimmy your data to say, hey, I want to really show that a lot of scores were in the 80s and 70s, and we want to order that. We want to make that look really good. So now the scaling is out the window. You're just ordering it according to the frequencies of numbers in those particular intervals. Least to greatest or greatest to least. So that's what a Pareto chart is. Then an ogive is a cumulative frequency graph with scaling on the x-axis. So you're just counting. So through the 80s, we have 16 total numbers. Let me zoom in a little bit. Through the 70s, we have 9 total numbers. Through the 60s, 2. So it shows some accumulation of things. So if you have a business, it might be good to use an ogive to represent cumulative amount of money that you have spent on something. The stem and leaf is designed to record individual scores. So a lot of times teachers that are trying to record scores, let's say on a final exam, and they would use something like this, and it would just give them a real good idea, picture idea of where a majority of the scores fall. So small amount of data and individual scores are highlighted with this. So not incredibly useful, but useful to the individual. Random graph problems. So on this assignment, what you should try is these random graph problems. So the very first one here is the weighted mean. So we're going to take 5 scores at 0, 5 times 0 plus 8 times 1 plus 11 times 2 plus 6 times 3 plus 3 times 4 plus 2 times 5 over the sum of the frequencies. So over 5 plus 8 plus 11 plus 6 plus 3 plus 2, which is 35. So that's why I started listing like all the zeros. So it is just a straight average, but who wants to do 0 plus 0 plus 0 plus 0 plus 0? And then 1 plus 1 plus 1, 8 times, then 2 plus 2 plus 2, 11 times. You get my point. So you multiply and then divide by the sum of the frequencies. Don't get confused. It's the sum of the frequencies, not the sum of whatever it is you're talking about. It's how many times, the count. I guess the count is the best thing to say for what's the count of everything? Count of everything is 35. The sum of everything is 70. Okay, so just a couple more questions. The sharpest increase in profits are right in here, wherever the line is steepest. In what interval is the lower quartile found? So you need to, what's the middle position with all of this? So 7 and 4 is 11, and 6 is 17, and 3 is 20. So there's 20. So the middle position is between 10 and 11. So 11 and a half, if you wanted to think that way. So right around 5 into it. So it's going to be, so this is really a confusing question. So it's starting here. So when we hit our 5th data element, it's going to be in the interval 11 through 20. So you got to think like 5, 10, 15, 20. Try to do it into 4 equal groups because that's what quartiling is. So like 0, 5, 10, 15, 20, but those are the counts. So you got to go to your 5th count, which is 11 through 20 for the lower quartile. All right, so 78 inches tall. So you just want to go across. And that hits 15. Okay, which information, best described? So hotels tend to be busier during holiday period. So the lower it goes, that's the vacancy, meaning they're busy. So summer, yep, December, pretty low. Pretty much common sense. Number 6, here we go. And this is a little hard to read. So remember I talked about, this is a circle graph, like your totals of 360. So it's not talking about angles, but like the total amount that this represents. So total expenditures during a year period. So they spent 22%, so a little bit hard to read here, on housing, 22%. So 22% of what number is 10,780? So maybe a better way to write that, 22% of what number is 10,780? So you solve for that and it's 49,000. So then it's 17% on food. So then you do 17% of 49,000, which is 8330. So those are probably a little bit better way. So this still is dealing with percentages, straight percent problems, percent of the whole. Okay, 17% here. How much did they spend on food? So the key was this number here. What's the total amount they spend in 1 year? Their income, I guess, made in 1 year. Okay, a couple more here, and then we'll move along. So what's the difference in the absentee rate? So about 2% here and 3% here. So 2% of 1260 minus 3% of 840. And it's 0 because they're both the same number. Interesting. Number 8, 70 or above. So how many? So we have 6 and 5 and 4. This is 3 and 2, but we're not concerned. So 6 plus 5 plus 4, 15 out of 20 scored 70 or more. Okay, so here's some calculations with outliers. I'm not sure that you would have to do this, so I'm probably going to bypass this. But it does show up here how you do it. You need to know your Q1 and your Q3. So this would be using a graphing calculator, probably enter these in and get these established. And then you would just use these formulas to do this. So I'll do one lower boundary calculation, then I'm going to move on. But you would need to know the lower and the upper quartile, the Q1 and the Q3. So Q1 15 minus 1.5 times 14. So 14 is Q3 minus Q1. So you do that calculation. That would give you the lower boundary. Anything outside of that would be considered to be an outlier in that set of data. And then this upper one would be 15 plus 1.5 times 14. So in that data, we have 1, sticks out like a sore thumb too. So I'm going to bypass this now. You're probably not going to have that, but you might have a question on this end game stuff here. So skewing of data. So data that looks symmetric, kind of, you can put a approximate symmetry line down it and get equal halves. So this one too, we can get equal halves. Both those are symmetric. And then skewing is where the data set is pulled in, like tailed in one direction. So you see like right here how, if I just put this curve, like it's tailing off to the right a little bit. You see like here, how I write this over, like it's tailing off to the left a little bit. So we call that skewing right and skewing left. So outliers cause skewing. So what would happen, most of the data is over here. And so some of these values to the right would be called outliers and would pull when you start averaging it, would pull the average to the right. Same way here, you got some of these lower values. Well, most of the data is over here. And you go to do a mean, it's going to pull that mean to the left. So that's why we call it skewed left. So this one, you kind of imagine the little curve over it, and you see the tail there. So it's tailed to the right, skewed to the right. And then this is not. Uniform just means that we've got straight across. It isn't, the values are not varying at all. So skewed right, tailed left, think that way. And so there could be questions on that. Questions on standard deviation. So I'll just be very simple here. Standard deviation is the typical deviation from the mean. So if we look at this data set, and this is all I want to talk about is this main one here. So the mean is 75. You can see that without doing anything. And the standard deviation exists to be added and subtracted from the mean a number of times. So when I take 75 and I minus 25, I get 50. And I take 75, add 25, I get 100. And all the scores are 1 standard deviation away from the mean. You use the standard deviation to add and subtract from the mean, and it describes the spread of data. So about 10% is a good measure. It's a good value of standard deviation relative to the mean. So it's always relative to the mean. Here, this is not a good set of data because the standard deviation relative to the mean is too high. Okay, so the rest of this is just adding. So what do you do with standard deviation? Well, you add and subtract it from the mean. So here we did it 1 time. So that's where most of your data would lie. And then here we kind of went backwards. We gave the results 1 standard deviation. So find the halfway in between, and then it's 21. So 43 plus 21, 43 minus 21. It's pretty simple. So here, outlier, different way of doing outliers, 3 standard deviations. So 72 minus 12, 3 times. And 72 plus 12, 3 times. And remember, you know, if I did 12 over 72, about 10% is what you want. That's a high standard deviation. That's about 17%. So you typically want it around 10%. That's a good measure. All right, and then questions on least spread out to most spread out. So obviously you can see here, that's more spread out than this, and then than this. So least to most. Least to most. Fox and Whiskers. So when you look at, you know, stem and leaf, so this is the most compressed, like if you just did a little, think the center line, the center of it. So this is the most spread out because it has the least number of numbers in the middle, and it's got 2 that are 1 notch away there. So I had to pause for a second. So you want to focus on this middle branch and all of these. And so if you notice how you have the most numbers in this middle here. So, and all the labels are 0, 1, 2, 3, 4. So this one is the least spread out. This is number 2 because we only have 4 that are out of the middle. Here we have 6 that are out of the middle. So this is more spread out. And you apply that idea to these also. So this is the least spread out, and then this is 2, and so we have the most dots away from the middle on 3, and the same concept on all of these. So think about the middle line through it. This is the closest together. This is number 2, and this has, so the middle line would be right here, the most data that's farthest from the middle line. And same way with these curves. So curve 3 here has the most data that's left and right of the middle line that would go. It's a little bit confusing, but you need to think of the middle line. I think I'm going to end the video. You could have a question on correlation. I think the 2 things I want to say. So positive correlation is just uphill left to right, and you want to be fairly in a line. No correlation means things are all over, and then negative correlation means downhill left to right. You can think of as one thing, this is another way, increases together, they both decrease together, and then negative correlation is opposite things happening. So as one thing increases, another thing is decreasing. If you see a scatter plot like this, you're very likely to be asked a slope question. Okay, so that you got to pick 2 points and do a slope calculation. And there's the whole correlation versus causation. So like ice cream and sunglasses, they're positively correlated because people are going to eat ice cream and wear sunglasses because it's hot out. but one does not cause the other. So there's all this stuff that we argue about with data, correlation versus causation. They're just correlated together. They both appear at the same time and they increase in usage at the same time because there's an outside cause, hot weather. All right, I'm going to end this. This pretty much was just an informational statistics video for you to sharpen up your knowledge.